Hi guys, welcome you all to my channel Explore Edu to Teach.
Topic that we are going to learn today is going to be network analysis. Already a detailed video on network analysis, basics of network is uploaded on my YouTube channel in network analysis playlist. However, this lecture will be oriented towards some problem solving in basics of network, wherein we have picked three gate problems. The first gate problem revolves around some theorems of Thevenin. The next gate problem will revolve around simple KVL and KCL, and next gate problem will revolve around star delta transformation. So we'll try to learn concepts also through this problem and learn how to implement and apply these concepts onto numericals. So we'll be learning these three problems. So please listen to this video completely. If you like this video, do not forget to like, share, subscribe to my YouTube channel. Also, the notes will be uploaded on my Telegram group. So the links of my Telegram group are given down in the description box. You can please join my Telegram group for all the notes, and all the formulas and short notes. The short videos are uploaded on my Instagram page. The links to which are also given down in the description box. You can follow me on Instagram for all the updates. So the first question is basically on this numerical. So this question was asked in GATE 2007 EC branch. The question says, we have a dependent voltage source named as 2I. The I current is basically flowing through this 1 ohm resistor. Then we have 1 ohm resistor. We have a 1 ohm resistor. We have a 2 ampere current, and we have a 2 ohms resistor. Find the Thevenin voltage and resistance looking into XY. So you have to find out the Thevenin's voltage and the resistance, that is VTH and the RTH. So what is the step to find out VTH? So VTH is basically the voltage across these two terminals, open terminals, you can say. So what we are going to do is that since VTH is the voltage across these two open terminals, this VTH is common to this 2 ohms resistor also, to this 2 amperes current source also, because they are in parallel. So applying nodal analysis at this node, we are going to have the nodal analysis formulas. So we are going to assume the current is outgoing, hence we have VTH minus 2I upon 1 ohm plus VTH upon 1 ohm. This is incoming, but we are assuming the current to be outgoing, hence minus 2 ampere plus VTH upon 2 is equal to 0. So we have this Thevenin's voltage diagram in which we have these two terminals. The voltage is given as VTH, and the VTH formula is VTH minus 2I upon 1 ohm plus VTH upon 1 ohm minus 2 ampere, because we are assuming the current to be outgoing. This is the incoming, we are minus 2 plus VTH by 2 is equal to 0. Hence if you solve it further, you will get I is equal to VTH. So this is one equation that we got. Okay, so basically we have got this, the first equation as this. Then your I, if you look at this, is equal to what? VTH upon 1 ohms, right? Because 1 is parallel to this open source voltage VTH. Hence your I will be equal to VTH upon 1. Now substituting this I value is equal to VTH upon 1 in equation 1. So substituting 2 in 1. So we have this value of I is equal to VTH in 1. Hence you will get the final answer as VTH is equal to 4 volts. The next term you to find out is the short circuit current ISC. So we are going to basically just short circuit this open terminal, and you are going to get ISE. For this ISE, you have to find out the value of the current. So how you are going to find out this value of ISE? You are going to find out basically by some simple network analysis problems. Now if you look at this particular thing, this is a short circuit, right? Isn't this a short circuit? So since this is a short circuit, I can say a resistor in parallel with a short circuit is always redundant. Hence Since this short circuit is in parallel with 2 ohms 1 ohm resistor, you can directly remove this resistance because they are redundant, they are of no use. Okay, therefore I can say if I am removing this resistor, the resistance is equal to infinite. Now since I am telling that 1 ohm 2 ohm resistor are in parallel, the current I is equal to 0. Therefore, if I say the current I is equal to 0, because this is an open circuit, right? Therefore, I is equal to 0. Therefore, I can just, now if this I is equal to 0, this 2I is also equal to 0. So, when a particular voltage is 0, we can replace it with short circuit. Hence, the diagram gets replaced with this. So, again you find that this 1 ohm comes in parallel with this 1 ohm, with this short circuit. Therefore, finally you can say ISC is equal to 2 ampere and RTH is equal to VTH upon ISC. 4 upon 2 ampere is equal to 2 ohms. So I'll repeat this question. If you look at this question, we have 2I as the control voltage source. You have 1 ohm, 2 ampere, 2 ampere. The Thevenin's voltage VTH is the voltage across this open terminal. This is in parallel with 2 ohm resistor, 2 ampere current and 1 ampere and 1 ohm resistor. So basically, assuming that the currents are outgoing, we have VTH minus 2I upon 1 plus VTH upon 1 minus 2, because it's an incoming, we are assuming all the currents to be outgoing, minus 2 plus VTH upon 2 is equal to 0. This is the first formula. The I formula, the formula of I is given as VTH upon 1. Therefore, substituting this 2 in 1, we get the value of VTH. Now, once we get the value of VTH, the value of ISC is given as, just short circuit this X and Y. If you short circuit this X and Y, how do you find out the value of ISC? Now, this short circuit is in parallel with 2 ohm resistor and 1 ohm resistor. So, whenever there is a short circuit parallel with a 2 ohm resistor and a 1 ohm resistor, definitely they will be redundant. Therefore, I can just remove them off, and when I remove them off, what happens is that this I value becomes 0, because since the resistor is removed, the resistance becomes infinite and the I value becomes 0. Since this I is 0, the 2I also becomes 0. Hence, the voltage source becoming 0 means that I can replace with a short circuit. Now, this 1 ohm is in parallel with a short circuit. Hence, finally, you have a 2 ampere ISC. Therefore, RTH is equal to VTH upon ISC is equal to 2 ohms. Fine, that is important. The next question that we have is basically asked in GATE EC 2010. Okay, so what is told in this question is that in the circuit shown, the power supplied by the voltage is, so you have a voltage source, right, 10 volts. So what is the power supplied by this voltage? So you know that the power is equal to V into I. The V value is given, I you need to find out. So how are we going to find out I? So look at this diagram. Since I is coming from here and this 1 plus 2 will be equal to 3, I can say 1 plus 3 will be equal to 3 plus I. That is very important circuit diagram. So you have 1 ampere current, 2 ampere current resulting to 3 ampere current. Wow, I over here, therefore you have I plus 3. Therefore, applying KVL to outer loop, you have plus 10 minus of 1 into 3 plus I minus of 1 into 3 plus I. Now, when you come to this resistor, from this 3, 1 is gone. Therefore, you have 2 plus I into 1. Again, minus of 2 plus I into 1 is equal to 0. So what we have to do is that in this question they ask you to find out the power supplied by the voltage source. The power supplied is basically V into I, as I mentioned over here. The V is given, I you need to find out. So just try to solve it via KVL. I is this, 1 plus 2 is 3. Therefore I plus 3 is 3 plus I. Just try to apply the KVL in the outer loop. the I value is equal to 0. Therefore, the power supplied is again equal to 0. The next concept that you have is a star delta transformation, in which you have basically a delta that gets converted to a star, and then you have, so basically they convert to a star, and then you have a star getting converted to a delta. So I just tell you to remember this formula basically if you want to solve questions on such kind of topics. So when I have to convert this into star, the star will be this. So this resistance is equal to R1 into R2 upon R1 plus R2 plus R3. Similarly, this resistance over here is the multiplication of its side resistance, that is R1 into R3 upon R1 plus R2 plus R3. Similarly, this resistance over here from C will be the multiplication of the two resistors, that is R2 into R3 upon R1 plus R2 plus R3. If I want to convert star to delta, I have a star mentioned over here and I need to convert that to delta. So in that case, what happens is that this value of AB resistance is equal to R1 into R2 upon R3 plus R1 plus R2. Similarly, this AC resistance is given as R1 into R3 upon R2 upon R1 plus R3. Similarly, this resistance BC is equal to R2 into R3 upon R1 upon R2 plus R2 plus R3. So you have to understand how do you convert a delta into a star and star into a delta. And on this basis, we have this question which was asked in GATE EC 2015. A straightforward question on star delta. If you know these two formulas, you can solve this question. So basically, they ask you resistance across this AB. Each value of resistance is 1 ohm. So we initially assume it to be R, and then we replace this R with 1 value. So what we are doing is this delta over here, R and R and R, we are converting into a star. So we have a star coming over here, and this value will be given as R by 3, R by 3, R by 3. Just apply this formula. So if you see, what does the formula to delta to star say? R into R upon R plus R plus R, which will give you R by 3. Similarly, R by 3, R by 3. Just add this R by 3 plus R by 3 plus R, and R by 3 plus R. Again, convert that R by 3 plus R by into delta. So you have a delta over here, and so delta over here. So if you see this question, we have just added this series resistance and converted this star to delta. So what happens is that the formula is 4R by 3 upon 4R by 3, 4R by 3 into 4R by 3 upon 4R by 3 plus 4R by 3 plus 4R by 3. This one, this into this upon this plus this plus this. Just see the formula over here and apply it. You will get again a delta. So what happens is 4R and R are in parallel, 4R and R are in parallel, 4R and R are in parallel. So just simplify it, then add this two series, it's again in parallel with this, and finally it is 8R by 15. The value of each resistance is 1 ohm. Therefore, 8 into 1 by 15 is 8 by 15. So basically, there are three important concepts which are being taught via this particular method. One is the concept of Thevenin's voltage and Thevenin's resistance. The other is basically the concept of your KVL, KCL in terms of the power delivered. And third concept in terms of the star delta transformation. So understand these three formulas very well. And these three problems are asked in the GATE examination also. So I've tried to explain the concept. All these concepts are also explained in a detailed manner in my network analysis playlist also. I'll put the network analysis playlist link also in my description box so that you can go and watch it from there. So if you like this video, don't forget to like, share, subscribe to my YouTube channel, follow me on Instagram as well as on my Telegram group, and share it to as many students as you can find, so that many students can get benefited out of it. Not only the students who are appearing for GATE examination, but also the students who are preparing for other exams, because these are just common concepts which can come in any examination. So thank you so much.